In this video, we're going to talk about the signs, positive or negative, or zero, of Ixy for areas located in different quadrants in the XY coordinate system. We already talked about this using the definition of Ixy of being the integral of xy dA. We're basically doing the same thing in this video, but now we're going to use the parallel axis theorem for Ixy, since we now know the parallel axis theorem, to reach the same result. This idea of Ixy being positive or negative in different orientations in a coordinate system is a common test question, conceptual test question. And so it's something you need to know and will be helpful to you. In our original introduction, we used the definition of Ixy, the integral of xy dA, to discuss that an area in quadrant 1 will have a positive Ixy sign. An area in quadrant 2 will have a negative sign. An area in quadrant 3 will have a positive sign. And an area in quadrant 4 will have a negative sign. And so we base this on the definition, the integral of xy dA. In this video, we're basically going to do the same thing, but now we're going to use the parallel axis theorem since we now know it, since we derived it. So, and I'm going to do kind of an example problem. And so here's an XY coordinate system, and there's 5 different areas. There's area 1, which is centered at the origin. There's area 2 in quadrant 1, area 3 in quadrant 2, area 4 in quadrant 3, and then area 5 in quadrant 4. We're going to use the parallel axis theorem to determine the sign of each of these areas. So remember, the parallel axis theorem says that Ixy is equal to I bar Ixy plus A dx dy. Because all of these are rectangles or squares with an axis of symmetry, then all of their I bars are 0. So the Ixy for each of these guys is just equal to their A times dx times dy. And so we can actually build a table for all of the 5 areas. Each of them have the same area, an area A. Each of their I bars are 0. But then if you look at the dx and dy values to each of these areas, for area 1, the dx and the dy are 0. For this area, the dx is positive, the dy is positive. For this area, the dx is negative, the dy is positive. So remember, dx is measured from the y-axis to the area. dy is from the x-axis to the area. For area 3, dx is measured from the y-axis to the area, so it's negative. dy is measured from the x-axis to area 3, so it's positive. For area 4, the dy is measured from the x-axis down to 4, so dy is negative. And for area 4, dx is measured from the y-axis to 4, so it's a negative dx. And then finally for 5, the dx is measured from the y-axis to 5, so it's positive dx. And the dy is measured from the x down to 5, so it's a negative dy. So compiling those in the table, so area 2 is positive dx, positive dy, positive, positive. Area 3, the dx is negative, the dy is positive. Area 4, the dy is negative, and the dx is negative. And area 5, the dx is positive, and the dy is negative. So for each of these areas, their IXY about the XY axis is basically equal to A dx dy, either positive or negative. And it's really depending on the dx dy product. And so area 2 is a positive A dx dy. Area 3 is a negative. Area of quadrant 4 or area 4 is positive, and area 5 is negative. So applying that to real problems, if you basically have a problem that has, let's say, an area that has kind of a dog bone shape, where most of its area lies along a line that extends from quadrant 1 down to quadrant 3. And we can model that by an A1 and an A2 here, 2 inches, 2 by 2 by 2. And so the IXY for this shape that lies in this along this diagonal is the sum of I bar plus A dx dy. The I bars are 0 because these are squares or rectangles. The area is 2 by 2. For A1, dx is positive 1, dy is positive 1. For A2, dy is minus 1, dx is minus 1. But the IXY then is positive 4 plus positive 4, which is 8, positive 8 for an area that lies along this diagonal is positive. An area that lies along this diagonal, some kind of dog bone, some kind of area, something like that, is going to have a negative IXY. And so let's prove that. So again, we go up a 2 by 2 and a 2 by 2. The area is 4. The dx is negative. The dy is positive. The dx is positive. The dy is negative. And so you use the parallel axis theorem to evaluate these. And the IXY for this shape is a negative 4 minus 4 is equal to negative 8 inches to the 4th. And so in general, an area that lies at this diagonal is going to have a negative product of inertia. So this is a common conceptual question on an exam. We'll review it again. We'll work some example problems that show this as well. We'll later work some practice exam problems too that show this. But again, this section or this current collection of videos are like introductory topics, general overview topics of IXY. And one of those overview topics is the sign that IXY takes on for different kinds of shapes.